Hello everyone, I'm Stas and welcome to my new TouchDesigner tutorial. And I want to show you how to create and explore the two-dimensional raycasting and shadow casting system. Well, at least kind of. Usually when we're talking about raycasting and two-dimensional raycasting, it's quite often used in pseudo 3D games like Wolfenstein and Doom and everything. But we concentrate on shadow casting because it's very interesting, visually interesting looking effect, like this one here, or here, or here, and here. Traditionally, in a raycasting system, all these blocks for the shadows are generated with SDF, two-dimensional. Well, it's shapes defined by math. It's kind of similar to ray marching, but two-dimensional. However, in my setup, I will use the texture for texture like this TouchDesigner bananas or anything else, because with texture you could use as an input for shadows Kinect or web camera or maybe render or pretty much anything. So it's not a very traditional Raycaster, but still. Okay. In a way, the setup is a little bit similar to God Rays effect that I showed about half a year ago in other tutorial, so you could also look that. I will leave a link in the description or somewhere here on the upper right corner. And to explain how it would be done, here I created a simple feedback loop because maybe for many of you it's easier to understand how it works in top operators or in TouchDesigner operators rather than in GLSL code. So if I stop this coordinates, here what we're gonna do. We have our texture with object for casting shadows, and then every frame we're gonna scale it a little bit more in a direction opposite from a position of the light. So if the light's here, we scale this rectangle or anything else a little bit more, so every frame it would be more and bigger and bigger and bigger. And also then turn the opacity a little bit. But with a feedback system, the problem is it's way too slow because it's only once per frame, so not much, and we need much more. So here is our GLSL code. I will share this example with everyone on my Patreon on a post that would be available for everyone, so you don't need to be my Patreon supporter, but if you wanna get this as well, it's only for the patrons, but I'll explain it a little bit later. Let's first see how the basic works. So I wouldn't create anything from scratch, but rather I'll explain you how it works. The simplest version is using two textures, one for the shadows or for the object that would be a shadow, like this black rectangle, and one for the light or anything else. But you still need to give a position of the light to the shader as well, so it's the same position of the light here and here. Well, because GLSL it goes from 0 to 1 here and in top operator the center, the 0 is here, so here is minus 0.5 and here plus 0.5. I'll rescale it a little bit, but it's just a difference between how the screen space organized, so from 0 to 1 or from 0 to minus 0.5 or to plus 0.5. So let's dive into code. The code is here. I'll probably do it like this. So with texture, the code is pretty simple. Here I have a pixel position, which is just a TouchDesigner variable called VUVST, but I save it to pixel position just to make the name more easy to understand. And I have this for loop to generate this kind of feedback system, but very fast. It will run with my setup here 100 times per frame. But to show you how it's done, instead of this for loop, now I'll show you one step. And also I'm gonna stop this, well, let me find a good position. Oh, light, please go to the nice position where I would like to see a shadow. What's going on? Oh, yeah. Yeah, sorry. Okay, let me stop somewhere here. All right, now we have a nice shadow and very easy to explain. So once again, I turn off this and I turn this one. These two lines are almost the same as these two lines, but instead of this for loop, when every time I have a different number, here I show you on a, so when the integer equals to 1 or to 0, well, to 1. To 1, I have this just blocking rectangle. And then with this loop, every time the I increases until it hits the number like 100. So what we're gonna do? So every step, this this rectangle goes on the direction opposite from the direction of the light and becomes a little bit bigger and bigger until it hits the number of 100 in this particular setup, and it disappears completely in 100. Oops, not 1100. Okay. And so this is a kind of similar to what's going on with a feedback example above. So when we switch it, okay, and also probably I need to explain to you how this function is organized. To this function we give two arguments: the current pixel, so for every pixel on the screen it would be evaluated individually, and our light position. And this is a variable t that would be different for every step in for loop. And this position, this iterational position, will be used to gather, to fetch a texture. When on the first step of a loop, The texture will be the same as here, but every time we scale it a little bit, so it moves away and away and away and away. And here we have just a smooth step function for interpolate the texture a little bit. Or if you want, you could use linear interpolation instead. It's not so much visible in this demonstrational example, so let me switch back to the for loop. And also, as you could see, if my raise number, the number of iteration for this loop, if it's too small, you get this very steppy result. So you need at least 100, and it's still a little bit blocky, so probably 500 would works very well. But the more this number is, the slower it would be. Probably for such a simple setup it still not affects FPS a lot, but in more complex setup it could affect a little bit. So another solution would be leave it at for example 100 and then add a blur, which can also blur the shadow. And the third option is to use this smooth step function to change the if you look closely to this and this line, depending on it would be probably more easier to see when we have not a simple rectangle, super black, but this rather a grayscale-ish noise. So if I switch to noise, by changing the parameters, I can affect a little bit of how the shadow is generated and smoothed. Is it very smooth or not so very smooth? And here I'm using the smooth step function, but instead you could use mix function, which produce a different result. So it's just your personal preferences. Most of the time I prefer smooth step. Or you could use anything else if you want. Or maybe you would like to every step not only doing this texture, but maybe doing something else as well. So let me switch back to the rectangle. So now this function returns the obstacle for every step, and every step we multiply it in the variable called brightness. So in the end we have this mask that would look like this. And then we just multiply our color, which is second texture, this one, and get this result. And the benefits of using the texture is that you could use not only just a boring circle light, but do something else, like, I don't know, maybe this triangle light, or not using the circle but using something completely different for the SLI source. But still you'll need light position only in this single light example, only one light position, and feed it as a variable to your shader. So but sometimes the using texture, it's not very optimal, especially in a situation like here, when you want to have a lot of light sources. Here I have a light position and light sizes and light colors. because you need to feed a lot of on the one hand you need to feed a lot of light position to your shader, but if you thought about making the same setup here with the texture, you will need somehow to generate a lot of circles here as well with the same position. So it should be a rendering on something. It's not super easy to do. So the different way of doing this is using dist function. And so let's look into this example, which almost the same with several differences. Let me again depose the light moving. First of all, here I have a little bit ugly solution, but it works for calculating the ratio, aspect ratio for my output. Because if I turn off this loop, my light would be in the shape of the aspect, it would be not circle, but the aspect of input top. So if I change input to something like 200, 100, it would be this circle, oval shape, and or the opposite, like 200 one. Well. So you got it. I hope you got it. Let me switch back. So that's why I need to calculate the ratio. So what's going on here? If we compare these two setups, here I multiply the color here in first example is just a texture, and then I multiply the brightness, the color to the brightness. And here, instead of doing the same, first of all, I use the separate, just a tiny 1 pixel by 1 pixel top to pick in a color, because it's much easier to pick color here rather than do it manually. With just the numbers. So it just feeds a number of a color here, the pixel values. Okay, so I have this color, and the multiplication to this color is in the end, but the brightness is calculated a little bit different. Here I have a distance function, and the distance is a distance between the pixel position and the light position. And the smooth step is just generated a ramp or a gradient between this value and this value. So if two values would be the same, it would be just no gradient, just a circle. So what this formula does is, if a length is a distance between, for example, this current pixel and the light center is this, it's more than 0.5, it's just completely black, or 0, 0, 0. And if it's less than 0.5, it's light source. And that's why it's generated just a simple circle. So if I decrease this number, the less pixels would be in the distance of 0.2. Oops. And this line here is just for adjusting it a little bit more. For example, here, if I from 0.05 to 1.2. Here is my basic setup, my basic gradient, light gradient. By using the power function, I can manipulate it a little bit more, like because these two numbers is manipulating the gradient itself and the distance, and this parameter is a power function that could affect the whole gradient. Okay, 0.5, 0.5, something like this. And probably there is no more. Yeah, and here I'm using the different interpolation function, but yeah, as I said before, it's up to you which one to use. So overall, this thing is creating a circle with a certain distance from a pixel. Okay, and I don't need the texture anymore. Okay. And this was a basic setup with a single light, and you could get it in the post. I will post a link below in the description below. But let's move on to these Patreon examples, because even if you are not my Patreon supporters, I'll still want to explain you how you could create it by your own. Here I have a lot of top noises to create a color of a light. Here I have RG for the position, because we have a two-dimensional position. This one noise I'm using for defining the radius of the size of this particular corresponding light source. And this one is for gradient, because here I don't have the same parameter as here as a light gradient, because it would require the 3 parameters for each light. It's probably too much, so I simplify it and use just 1 parameter for fading, and I pass it to the shader. And here I have integer variable that generates a number of a light, and it's just bind to these noises. And if we go inside, it's again almost the same. The difference here is that I have 2 for loops. It's not super efficient, but I decided to do it like this because it's much easier to understand if you just a GLSL beginner, because for every light you're doing absolutely the same stuff as you did before, but you just do it for every light and then calculate the gradient of a light and the size of a light, and in the end you just sum the lights for every source. And also I have this clamp function, because if I wouldn't do it, the lights from every light source isn't just an additive model, so it will add up and add up, and sometimes it produces glitches when the values are much more than 1. So here are the clamps, so the maximum value for the color would be 1, which for every channel. So if all 3 channels would be 1, it's just a white light. And here you could see when the several lights meets in one spot, it's just become a 1 light. And so here as a fade, I'm using it for the distance of a gradient, and this one size is just for the size. So if I offset it, the lights would be too big. But again, it depends on what you would like to create. For example, if you like, maybe you would prefer to create effect more like this, and then you will have to do a bigger offset, but maybe to decrease somehow this super whitish color, maybe clump to less value or multiply a light to divide light to something, or maybe use just the different colors, or do whatever you want. Anyway, it still works. Okay, so if you want, you could create it by yourself, maybe use some more optimal solution than mine, or maybe just copy this position, or if you're one of my Patreon supporters, you could just download this file and manipulate it with it. And another example I'll share to my Patreon supporters is this one. Again, it's a single light, but instead of making light as a circle, I make it as a cone. So it looks, so my idea was to make it look like a car or a bike or anything. It's just manipulating the, for example, if I stop it, okay, here I need to oops, I forgot where my setups. Anyway, if you think about, for example, if I have the light is here, then my shadow is going dark in this direction. But imagine this here would be, instead of shadow, another just a tiny dot here. So if you have another little dot here, it would cast this shadow effect like this. So what if instead in the same loop you will create is you will cast it here, but not as a shadow, but as just a light. Then you will have this conal light here. And to do it, one of a solution, the simplest one, is use the current light position and the previous light position. So every time you would have these two positions that would be very, very similar, very close to each other, but the previous position and current position would, the vector difference between them will create this cone effect of a light. Right now it's not working because the values are the same, because feedback sometimes not working, but here when my light is moving, yeah, I also have a different light parameters, but the idea is to, in the same loop, is to also calculate the light position and to cast the light instead of shadow. And also here, which also could be interesting for you, here I have two color buffers, one for shadow and one for the light. And you could do the same with other setups. It will give you a possibility to composite this layer somehow. For example, here I create just I'm using an edge, so it will light up the edge of my blocking of my I don't know, houses. And then if you composited these edges with the light, it looks a little bit more like real shadows, because when you cast the light into some surface, the edge of the surface it's more lightened up, and then goes the shadow. It doesn't look super nicely here because I'm using a blur, so if I turn off, it's much better. But yeah, you could do it with a blur as well. And probably that's it for today. I hope this month was very busy for me, so it's not so much a tutorial this month, but still, if you're one of my Patreon supporters, I'm trying to post the different examples on my Patreon. So I also have this converted shader toy stuff, the feather roots, the sine wave example, and refracted GLSL matte with a little bit of text tutorial. So consider subscribing to me to Patreon, and see you next time. And I hope the next time would be not that you wouldn't need to wait a lot of time till the next time. So goodbye, see you, that's it.